Dear students, welcome back for the third session of this structure of an atom. Okay. So previously we have discussed, I think, the detailed classification with respect to only the crystalline solids, which is on the basis of the nature of the particles that has been present in that, and also the net interactive force or the type of the interactions or the forces existing between the individual particles. We can classify that as molecular, ionic, covalent, and then the metallic crystals. Okay. So now we will move on to the studying of internal structure of crystals or CS. CS means it is also called as crystalline solids. It is a crystalline solids. So this is done by, the structure of this one is done by X-ray analysis. The structure of a solid is detailed, usually studied by with respect to which one? The X-ray analysis. Means just we have to flash a X-ray on the given solid particle. Okay, and the photography of that has been observed through the photographic plate, such that I can observe the detailed structure with respect to the crystalline solid. Only we are concentrating on the crystalline solid because the particle arrangement is found to be what? Regular. That is why the X-ray analysis clearly decides the structure related or internal structure with respect to the crystalline solids, or sometimes it is simply called as the crystals. Okay. So here this is having the four different terms. First, some basic terms related to the structure of crystalline solids. What are the various basic terms that has been related to this? The first term is, what is lattice point, or it is also called as a lattice site. It is also called lattice point or lattice site. Then we are having the unit cell. Then we are having the third one is crystal lattice, or it is also called as space lattice. Crystal lattice is also called as the space lattice. And finally we will have the fourth one in the form of coordination number. Coordination number. So these are the basic terms that you have to study when you are observing the internal structure with respect to the crystalline solids. That is, what is lattice point, what is a lattice site, a unit cell, crystal lattice, or it is also called space lattice, and finally the what number? The coordination number. Let's have. It is the fixed position of the particle in the given which lattice? Crystal lattice. It is a fixed position of a particle. That particle may be either in the form of, as usual I have mentioned, it may be in the form of an atom or an ion, or it may be sometimes the which one? Molecule. Whatever may be the bond that has been existing between them. Okay, that is, any fixed position of the particle in the given crystal lattice refers to what point? The lattice point, or it is also called as the lattice site. Then what is unit cell here? So we can have the two different definitions related to this unit cell. The smallest repeating unit in the crystal lattice is called as, what is that? The unit cell. That is the smallest which one? The repeating unit with respect to the which one? Smallest repeating unit with respect to the crystal lattice refers to the what cell? The crystal lattice. Or it is also defined as, it is a group of or set of or group of lattice points which can be repeated in the three-dimensional nature of crystal lattice is called as, that's also unit cell. We can have the two definitions. The smallest repeating unit in the crystal lattice is simply called as unit cell. But how that smallest repeating unit is obtained? It is by the group of lattice points. What is group? Lattice point here? It is a fixed position of that, which can be repeated in all the three possible ways. That is a three-dimensional that leads to the what? Nature of the crystal lattice. Then what is a crystal lattice here? It is the three-dimensional arrangement of large number of unit cells. It's a three-dimensional arrangement of, either I can say that in the form of the lattice points also, or I can strictly say that it is a large number of what cells? Unit cells. Because unit cells is nothing but a group of which points? Lattice points. We can use either the three-dimensional arrangement of large number of unit cells, or it may be the three-dimensional arrangement of lattice points is considered to be the what? The crystal lattice, or it is also called as the space lattice. Then what is that coordination number here? It is the number of nearest neighbors. Number of which one? The nearest neighbors around the given lattice point. That lattice point, or indirectly it is a given particle, is considered to be the what? The coordination number. Okay? So I think this may not be clear even just if I have the imagination. Okay? Let's have the demonstrative with respect to this by taking one cube that is called as a cube first. So here, assume that this is a cube now. As if I have mentioned previously, a structure for NaCl. Okay? So let us draw that first one time, and then we will have the clear discussion about what that particular unit cell is. Okay? Let's have that first. So here, assume that this is Na plus, this is Na plus, this is also Na plus. I am writing that in the alternate ways. Okay? Now we will have the Cl minus, Cl minus, Cl minus, and then Cl minus. Okay? So as usual, the same cube that I have chosen here. Okay? So here at this part, there is a fixed position with respect to Na plus here. This is Cl minus, this is Na plus, this is Cl minus. Na plus, Cl minus, Na plus, Cl minus. Again, if I turn like this, if it is Cl minus means it is Na plus. If this is Na plus means it is Cl minus. Na plus, Cl minus. Means, what is the position of either the Na plus or the Cl minus? It is fixed. That fixed position of the particle, that particle I have mentioned that either it may be in the form of an atom or a molecule, or sometimes it may be the ions. Here, the position of Na plus is fixed, the position of Cl minus is fixed. And that particular fixed position is called lattice point, or it is also called as the lattice site. Lattice site means the fixed position of the particle in the given crystal lattice refers to what? The lattice point, or it is also called as the lattice site. Okay? Next, what is unit cell here? So how that particular cube is formed? It is having totally the 8 particles, in which 4 Na plus and 4 Cl minus are there here. 1, 2, 3, 4. 4 Na plus, 1, 2, 3, 4. 4 Cl minus. Means it is having the set of, how many set? 4 set of Na plus and Cl minus makes one picture. And that is considered to be the what cell? Unit cell. Means it is the group of lattice points which can be repeated in all the three-dimensional network in the given crystal lattice. That refers to the what? The unit cell. Next we'll have the crystal lattice. If this is one cube, I can put the another cube here, 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 and so on. Means it is a three-dimensional arrangement. So let us have this arrangement in the form of like this. Okay. Assume that each block is considered to be a cube. I will take this as a sample for that. Okay. This cube means it is having a large number of cubes inside this. This is the total structure with respect to the sodium chloride I am mentioning. This total arrangement is called as what? The crystal lattice, or it is also called as the space lattice. Means to get this particular exact structure, what you have to arrange? The large number of which cells? Unit cells. Whether it is only in the one direction or the two direction or all the three possible directions. The three possible directions. Means it is a space. That is why we are using the word as lattice. Lattice also called as the space lattice. Means it is a three-dimension. Means the three-dimensional arrangement of large number of which one? Unit cells. Because one cube refers to the which one? Unit cell. How I arrange the each cube now? One above the other, or side, or beside, or above for that. Means the three-dimensional arrangement of large number of unit cell refers to the which one? The crystal lattice, or it is also called as the space lattice. So if this is the case, which is the repeating unit here? One cube is repeating. One cube is repeating. And that smallest repeating unit in the crystal lattice is also called by another name. The same unit cell. Means we can have the two different definitions with respect to the unit cell. What is that? One thing is, it is having a group of which points? Lattice points. What that group? For example, 4Na plus and 4Cl minus set refers to one unit cell. And that is always repeating in all the possible directions. That is why the smallest repeating unit in the given crystal lattice is also called as what? The unit cell. Okay. Then what is that crystal lattice here? Arrangement. How you have to arrangement in the three dimension? What do you have to arrange? Large number of which one? Unit cells. Means if I arrange the large number of unit cells in all the three possible directions, then that particular total arrangement is called as the crystal lattice, or sometimes it is also called as the space lattice. So I think it makes it very clear. Okay. So let us have the last term, that is in the form of which one? The coordination number. What is coordination number here? The number of nearest neighbors around the given lattice point is called as which one? The coordination number. Means around each particle, how many nearest are there is considered to be the what? The coordination number. So let us have the assumption here. Let us assume the same cube here. Assume that this is Na plus, for example. This is Cl minus, this is Cl minus, this is Na plus. Okay. It gets arranged in three dimension. So according to this, how many nearest neighbors are there? To this, the first nearest neighbor is this, the second nearest neighbor is this, and the third nearest neighbor is this. Means what is its coordination number? 3. But it is not so. Why? Because the cube gets arranged in all the three dimensions. If I put another cube, I will get this one. Therefore, this is another nearest neighbors. If I put another cube, I will get another one is here. If I put another here, we can get. Means 1, 2 and then the, 1, 2 and then the 3. 3 already. 3 now on extension. Means 1, if I consider this particle as fixed. The first nearest neighbor, second nearest neighbors, third nearest neighbors. If I elongate this, this is the 4th, this is the 5th and this is the 6th. Therefore, how many nearest neighbors with respect to this one are? It is found to be the what number? Coordination number. Means if I select one particular point, that point is also called as what point? Lattice point. It is also called as lattice size. To that, how many nearest neighbors are there? Around that each particle is considered to be the what number? The coordination number. So I think to study the detailed internal structure of the crystalline solids, you have to be very familiar with respect to the 4 different terms called as lattice point, unit cell, crystal lattice, and then the which one? The coordination number. So what is lattice point? It is the fixed position of the particle in the crystal lattice is called as lattice point. What is unit cell? It is a group of lattice points which can be repeated in the 3 dimension is called as unit cell. It is the smallest repeating unit in the crystal lattice is also referring to the unit cell. Then what is crystal lattice or space lattice? It is a 3-dimensional arrangement. It's a 3-dimensional arrangement of large number of unit cells refers to either the crystal lattice or it is also called as the space lattice. Then what is coordination number? If I fix one point, to that point how many nearest particles are there? And that number of nearest neighbors with respect to the given lattice point and the particle is referring as what number? The coordination number. Okay, so these are the 4 different terms that you have to be very familiar when you are studying the which one? The internal structure with respect to which one? The crystalline solids. Okay. Next we will have the what are the various parameters that we have to know? What's that? The various parameters are the characteristics with respect to the unit cell. Either we can mention that as the parameters, or sometimes it can also be called as the characteristics of a unit cell. Unit cell. So here, unit cell with respect to the crystal lattice has 6 parameters in which 3 are edge lengths and 3 are axial angles. Okay, we are having the 6 different parameters to express the characteristic with respect to the which cell? Unit cell, in which 3 are considered to be the what lengths? Edge lengths. Assume that as A, B and C. So this is the axial angles are in the form of alpha, beta and then the gamma. Because as if it is a 3-dimensional, you have to have the 3 different edge lengths along the x-axis, y-axis and then the z-axis. So let us have the drawing of that. Suppose this is x-axis now. This is y-axis and this is z-axis. Okay. So here A is the edge length along the what axis? X-axis. B is the edge length along the y-axis, whereas C is the edge length along the z-axis. Therefore, what A, B and C are? They are the edge lengths with respect to which one? X-axis, y-axis and then the z-axis. Assume that. So, let us have the diagram with respect to that. Assume that this is a horizon here. Okay? Origin here. This is x-axis, for example, this is y-axis and this is the z-axis. This edge length is found to be the A, this edge length is found to be the B and this is the edge length that is found to be the C. Means A is the edge length along the x-axis, B is the edge length along the y-axis and C is the edge length along the which one? Z-axis. That's the first 3 parameters we are having called as the edge lengths. Then the 3 axial angles we are having, that is between B and C, it is called as alpha. Between C and A, it is found to be the beta. Between A and B, then it is found to be the gamma. So what is that here? They are the axial angles. What is alpha here? It is the angle existing between the two axes. What is that? Between B and C, means between Y and Z axis, it is found to be the alpha. Beta is the axial angle between the Z and then the X axis, or X and then the Z axis. Whereas gamma is the axial angle between the which and which axis? X and then the Y axis. Means any internal structure of which one? The crystalline solid with respect to the unit cell is characterized by totally how much? The 6 parameters, in which 3 are considered to be the edge lengths and 3 are considered to be the what angles? Axial angles. So here the edge lengths is nothing but they are the lengths with respect to the X axis, Y axis and then the Z axis, having the names of A, B and then the C. Whereas the 3 axial angles are, the axial angle is the angle between the two axes, two different axes. The angle between the B and C, or indirectly it is Y and Z is found to be the alpha, Z and X is found to be the beta, and then X and Y is considered to be the what? Gamma. Okay. So based on the values of A, B and C, alpha, beta and gamma, totally we are having the 7 types of crystal systems. How many types? The 7 types of which one? The crystal systems. Okay. So let us have so here types of crystal systems based on the values of 6 parameters, that is A, B and C, along with alpha, beta and then the gamma. So we are having 7 types of which one? Crystal systems. Totally we will mention directly here itself. The 7 types of which one? The crystal systems, that is based on the which one? The 6 different parameters. That is, the parameters are A, B, C, which are considered to be the what lengths? Edge lengths, and alpha, beta, gamma are considered to be the which one? The axial angles. Okay. So let us have one by one first. The first one is cubic crystal, cubic unit cell. The second one is, the first one is found to be the what? The cubic, the simplest of the crystal system, we are calling that as what? The cubic crystal system. Next we will have the tetragonal also. Tetragonal. In the third we are having the orthorhombic. It's indirectly called as orthorhombic also first. Orthorhombic, sorry. Orthorhombic. Then we will have the fourth one in the form of the hexagonal crystal system. Hexagonal crystal system. Then we will have the fifth one in the form of rhombohedral. It is also called as trigonal also. Rhombohedral, or sometimes it is also called as trigonal crystal system. Then we are having the monoclinic crystals, and lastly we are having the triclinic crystals. What these are? The 7 types of which one? The crystal systems. Because the crystal system is decided by which one? The 6 different parameters called as A, B, C, called as edge lengths, and alpha, beta, gamma are considered to be the axial angles. Then, what is that cubic here? What's that cubic here? If A is equal to B is equal to C, A is equal to B is equal to C. What's the meaning of that? Length is equal to breadth is equal to height. Means all the edge lengths are equal. In addition to that, alpha is equal to beta is equal to gamma is equal to 90 degree. Means all axes are found to be mutually perpendicular to each other, with all the edge lengths are found to be the same, are equal, then that particular crystal system is considered to be the cubic. Okay? So just I will move on to the directly the opposite for that. What's that opposite here? A not equal to B not equal to C. Means length is not equal to breadth is not equal to which one? Height. Alpha not equal to beta not equal to gamma, and all are not equal to which one? 90 degree. There is no perpendicular nature with respect to that, but all the axial angles are found to be different. If this be the case, it is called as triclinic system. Okay, that is why this is the most symmetrical crystal, the most symmetrical crystal among the seven. And this is the most unsymmetrical crystal. Most unsymmetrical crystal is the triclinic. Dead opposite. If length is equal to breadth is equal to height, and all the bond angles or the axial angles are all equal, and they are always equal to the 90 degree, which are mutually perpendicular to each other, then it refers to the most crystal system, symmetrical crystal, that is called as cubic. Suppose if all the edge lengths are found to be different, means length not equal to breadth not equal to height, and all the bond angles or the axial angles are found to be different and they are not equal to 90 degrees, such that is considered to be the most unsymmetrical crystal system called as triclinic. Okay, so that's make the first and last. The most symmetrical is cubic and the most unsymmetrical is what? The triclinic. Now A is equal to B but not equal to C, alpha is equal to beta is equal to gamma is equal to 90 degree. What's the meaning here? The two sides are equal, means length is equal to breadth, for example, but it is not equal to which one? Height. Means the two sides are equal but not the third. But all are mutually perpendicular to each other, means axial angles are all equal to the 90 degree, then that refers to which one? Tetragonal. It refers to the unit cell called as which one? The tetragonal crystal system. And the third one is orthorhombic. A not equal to B, not equal to C, but alpha is equal to beta is equal to gamma, all are equal to which one? 90 degree, then it refers to which one? The orthorhombic. Means length not equal to breadth not equal to height, but the case is all the axial angles are equal and all are mutually perpendicular to each other, that refers to the which nature? Orthorhombic. Okay, so that makes the first three very clear. First make first and last very clear. What is that? The most symmetrical means all edge lengths and all the axial angles are equal and all are equal to 90 degree, it refers to cubic. If all edge lengths are not equal and all the axial angles are not equal and they are not equal to 90 degree, that is called as triclinic. Next, compare the cubic with the tetragonal and then the orthorhombic. In the first all three cases, all the axial angles are equal and all are equal to the 90 degree, that is mutually perpendicular. Such that if all the edge lengths are equal, it is found to be the cubic. If two sides are equal compared to that of the third, then it is called as tetragonal. If all the edge lengths are found to be different, then it is found to be the orthorhombic. Okay, so that is comparison of 1 and 7 and then 1, 2 and 3. This is how you have to remember. Okay, now hexagonal. A is equal to B but not equal to C. Alpha is equal to beta is equal to 90 degree, but gamma is equal to, for example, 120 degree. What's the meaning of that? So here the two sides are found to be what? Equal compared to that of this one, but the two angles are 90 degree and then the third angle is not equal to 90 but it is equal to 120, that refers to which one? Hexagonal. Okay. So let's move on to the rhombohedral. Rhombohedral means here A is equal to B is equal to C. A is equal to B is equal to C. But the thing is, alpha is equal to beta is equal to gamma, but it is not equal to 90 degree. Then it refers to trigonal crystal system, or it is also called as rhombohedral. All are equal or the bond angle is equal and that is mutually perpendicular 90 degree, that refers to cubic. All the edge lengths are equal and all the axial angles are equal, but they are not equal to 90. That refers to rhombohedrals. It is also called as which one? Trigonal crystal system. Trigonal crystal system. Okay. So next, the last one is, it is similar to this. A not equal to B not equal to C. It is similar to that of triclinic. Here alpha is equal to gamma is equal to 90 degree, but beta is not equal to 90 degree. Then it refers to the monoclinic crystal system. What is that? The monoclinic crystal system. But the thing is here, it is not adjacent to that the alpha is equal to gamma. It is not equal to beta. Alpha is equal to gamma. It is equal to what? 90 degree. Because don't make the confuse for that. Because between B and C, we are having which one? Between B and C, we are having alpha. C and A, I think it is beta. And then if it is A and B, then it refers to gamma. So here what we have chosen? Alpha is equal to which one? Gamma. Both are equal to 90. But beta not equal to 90 degree. That refers to the which one? The monoclinic crystal system. What system it is? It is called as monoclinic crystal system. Okay. So here all will have the first primitive cell. Primitive. So I will explain what that primitive is first. Primitive means it is a simple unit cell. Primitive means which are present only at the corners, means the particles only at the corners. In addition to that, we are having the body centered and then the face centered, that refers to cubic. That I will explain now. Okay. With respect to this, we are having only the primitive and then the body centered. Primitive and then the body centered. With respect to orthorhombic, we are having all the four types, that is called as primitive, body centered, face centered, and then the edge centered. We are having the what centered? Edge centered. So in the fourth and the fifth case, we are having only the what? Primitive. Then we are having the end centered. In this case, it is found to be the what centered? End centered. And finally, it is last. There is no chance of either the body centered or the face centered, or it may be the edge centered. Okay. Here P refers to the primitive. Primitive means where the particles only situated at the corners. If the particles are present at the center of the whole system, then it is called as body centered. If the particles are present at the centers of each phases, then it is found to be the face center. If the particles are present at the end centers, means they are in the opposite sides of the opposite phases, then it is found to be the what centered? End centered. Okay. So totally we are having 3 plus 2. 3, 2, 4, 1, 1, 2, 1. Totally 3 plus 2, 5, 5 plus 4, 9, 10, 11, 12, 13, 14. And these 14s are called as Bravais lattices. They are called as what lattices? The Bravais lattices. What that Bravais lattices are? The 14 different possible three-dimensional lattices. Means with respect to cubic, we are having the primitive, body centered and face centered. Whereas with respect to tetragonal, we are having the primitive along with the body centered. With respect to orthorhombic, we are having all the four possibilities like primitive, body centered, face centered, and then the end centered. And hexagonal and then the rhombohedral refers to only the primitive. Monoclinic is having primitive along with the edge centered. And finally the triclinic is having the same what? Primitive. Okay. So now we have to consider what is that primitive. unit cell, what is that body centered, what is that face centered, and what is that head centered. Okay, so that all we will decide in the next session, because we will discuss the type of unit cells, because as if I am concentrating only on this one. Why? Because that is the most symmetric. What is the meaning of most symmetric? All the edge lengths are found to be same and all the axial angles are equal, and strictly they are equal to 90 degree. That refers to the most symmetrical, and that refers to the which one? Cubic. As per the syllabus, we are having only one. What is that? The cubic. But here this can be asked for 1 mark. That is, what is the condition with respect to the, for example, hexagonal. For hexagonal, the two sides must be equal compared to that of the third, and then the two angles are equal to 90 degree and one angle is equal to 120 degree. Name the most unsymmetrical crystal system of the unit cell. It is the triclinic. Why? Because all the edge lengths are different and all the bond angles are, the axial angles are not equal, and they are not equal to 90 degree. That is why it is going to be the triclinic. So in that they will ask with respect to 1 marks. But the most important that we have to concentrate is about the which one? The cubic. That is, now we have to concentrate what are the various types of cubic unit cells. Types of which one? Cubic unit cells. Okay, so that I will discuss in the next session, or the 4th session of this particular chapter, that is called as solid state. Okay, so thank you.